Okay, so just some terminology so that, if I use these terms after this, you'll know what they are. So, an antigen is something that triggers the immune system. This could be little microorganisms in our body, even something as simple as like a splinter or pollen. So, it doesn't even have to be like an organism to trigger the immune system, like I said, like a splinter. Then a pathogen, though, by definition, is something that is causing a disease or is a disease-causing agent. And so this would be a virus and this would be bacteria. And one of the reasons why we can automatically tell, even if the virus had this shape, is the size of the proteins, because the viruses are so small. So in relation, their protein receptors are really big compared to their size, where bacteria are actually much bigger than viruses typically. So we don't see those bumpy proteins. They're there, but just in relation to the bacteria, they're much smaller. All right, so usually this is where I would ask a question like, okay, what is this girl getting? And a lot of people say shot, but hopefully with everything that's going on with this current virus, you understand that she is getting a vaccination, which is something that, they're still trying to work on for COVID-19. So the term immunity is when the body's cells remember certain antigens and pathogens and know how to fight them. And part of how some people, we just catch this, and you may have heard a term herd immunity, herd as in like a herd of animals. And it's a term for basically a population of people typically, but I guess it could be animals too, getting diseases, developing their immunity on their own. And then over time, the population or the herd has herd immunity as a group. And some would die and be lost in the process, but overall, the group would end up with the immunity. We're not taking that approach. We're doing the social distancing and quarantine approach. But there is a country in Europe that is trying to do or has been doing the herd immunity approach. So we eventually developed technology called vaccinations, where basically what they do is they inject a weakened virus into the organism to help build immunity. And then an example of that, a common example would be the flu shot. And one of the questions that I would probably be asking now of the class is why we need to get flu shots every year. And usually somebody understands that the viruses are mutating and evolving, and thus the flu changes every year, and that's why there's new flu shots. And so this girl is so a lot of people, like I said, they'll say she's getting a shot, which isn't necessarily wrong, but she's getting a vaccine or a vaccination. And I just particularly like this picture because it's kind of like varying degrees of panic the farther away you are from getting the injection. So he's kind of like more like wondering what's going on. This guy's starting to get worried, and she is freaking out. Okay, so this little chart shows us what happens after we have given our body time to develop an immunity. So the size of the graph represents the number of antibodies, another term you're probably hearing a lot about, antibodies with COVID-19. And we don't really make a lot of antibodies on our first exposure because we don't really know what the virus is. So you can see there's a little bit made, then it just stops. And then here's like some time passes, and then somebody gets the virus again. And then this time there's this much greater amount of antibodies being made because now the body recognizes the virus and knows how to make the antibodies. So there are two types of immune system defenses. And here we see that weird bacteriophage virus again. So we have non-specific defenses. These are constant defenses against any type of antigen. So these are just kind of like permanent defenses happening all the time. And that's why they're called non-specific. So we have skin and sweat barriers that keep things out. Mucus, this is why we get like boogers and phlegm and like whatever. Those things are being captured and clogged up. Here we see some natural killer cells, which are basically just kind of generic white blood cells that will just go after any antigen. And then also fevers. This is the raising of body temperature to try to destroy an antigen. And that's one of the few things we actually can do against a virus is temperature increase might destroy it. Because, as we've talked about before, antibiotics do not work on viruses. So we can't just take antibiotics and make the viruses go away. So here's like a splinter or something, and we're seeing the white blood cells going on the attack here. This is a white blood cell, or here, natural killer cell, going after, I think, some like cancer, basically like a cancer cell, and you can see it's kind of moving itself here, and now it's starting to kind of attack the cancer. Here's another picture of a white blood cell attacking some maybe cancer cells, and we can see the white blood cells surrounding this thing and starting to attach to it to try to destroy it. So we also have specific defenses. These are cell defenses for specific antigens where the body knows what they are. And what they'll make are kind of our main weapon are called antibodies. And these are proteins that identify and neutralize a pathogen by attaching to its receptors. And this is created and caused by the body's immunity. So now the body knows what weapons to use and makes the right antibodies. This picture is not super accurate. Normally in class in your diagrams, I would give you a better one. But it kind of looks like they're just like smashing into the virus. But these little Y-shaped antibodies latch onto the receptors. And once the receptors can't function, now they can't invade the cell like I talked about earlier. And they can become like neutralized. So they'll stay in your body, but they just can't do anything. All right, we're going to stop there because I forgot to set my timer and don't really know how long that was.